Okay. So I think we can start. I don't think you can imagine a better way to start your morning with a 400-level session on many-to-many relationships. That might be a good way to start your day and probably end it here. Welcome, everybody. I'm Alberto Ferrari. How many of you have already seen our session yesterday about Vertipack versus Tabular? All of you. Okay, so I can avoid a lot of introduction and avoid a lot of stuff. These are my details. I'm Alberto Ferrari, SaaS Maestro, MVP. You can find here all my contact details. For the session of today, and in general, whenever I speak of DAX, in reality, it's not important to see my face or to see just my titles. The important thing is that I'm a real fan of DAX. I really like BI, business intelligence, with the Microsoft stack. And in the last few years, I have worked with analysis services, Tabular, mainly Tabular. I'm no longer so focused on multidimensional. And today, we are going to speak about many-to-many relationships in DAX. I guess, who doesn't know what a many-to-many relationship is? Love you. Many-to-many relationships are simply relationships between tables which are not only one-to-many or many-to-one. They appear very often in data modeling. There are a lot of scenarios where we have many-to-many relationships. And on the slide, you can see a very common example of many-to-many relationship. We have the fact table, transactions. This is taken from a banking account solution. We have a fact transaction directly linked to date and to type. Then a transaction is linked to an account, but an account can be held by more than one individual. You can have many customers sharing a single account, and a single customer can have many current accounts. So this is a clear example of a many-to-many relationships. Of course, sometimes the bank wants to aggregate numbers using the account, but a lot of times they want to aggregate numbers using the customer name. And if you want to aggregate numbers using the customer name, of course, you have to traverse the many-to-many relationship, which is hosted inside the bridge, in order to get values. So a simple question like, how much money do Alberto have, is not very easy to answer, because I can have all the money of all my current accounts, or I can have just part of them. It needs to be studied. The problem is that in multidimensional, you have many-to-many relationship. You can model inside the data model many-to-many relationships, and even if they are not very easy, they work inside the data model. So you study the many-to-many pattern, you learn how to make it work, and then you are up and running. You do not need very complex knowledge in order to make them work. Performance are not optimal. They are not slow, but they are not very fast. But handling them is pretty easy. Tabular does not handle many-to-many. There is no way to write inside the data model a many-to-many relationship. Tabular only handles plain vanilla one-to-many relationships. And this is a problem. Since you don't have many-to-many, you cannot create a data model containing many-to-many relationship. You need to leverage the DAX language in order to handle them. And today, I'm going to explain in a great detail the classical many-to-many pattern, so how to make many-to-many relationship work with Tabular. And then, once we have learned the basic formula, which comes in different flavors, in different way of writing, and we will need to understand it really, really well. When we got it, then we are going to show different scenarios where many-to-many relationship might help. We have cascading many-to-many, that is more than one many-to-many relationship from the dimension up to the fact table. Then a survey data model solved with the many-to-many relationship. Basket analysis, again solved with many-to-many. And at the end, we'll do an analysis of performance of many-to-many in DAX. There, I'm going to show you again the 4 billion row fact table, but at that point, we will understand better how the formula works and why they work so fast. Okay, before Speaking about many-to-many, let's take a look at the data model in DAX and look how it works or how it doesn't work. I need to switch here and move to the first demo. We have a data model. This is Power Pivot. I'm not going to use Tabular because Power Pivot and Tabular at the end are the same engine, and Power Pivot is easier to use and to provide demonstrations. In this Power Pivot data model, you can see we have customers, then we have a bridge table and accounts. Accounts are then related to fact transactions. We even have type and date, but for the purpose of our analysis, date and type are not interesting. We are just interested in having customers, account, and transactions. As you might know, in DAX, if you put a filter context, oh, a question I didn't do. How many of you have a basic knowledge of DAX? Most of you. Okay. In DAX, if you create a filter context on a table, that filter context is automatically propagated from the one side to the many side. And this happens automatically. But it is not propagated from the many side to the one side. So if we create a filter context on customer, we are on the one side of a one-to-many relationship, and the filter context is propagated automatically to the bridge table. But then the problem we are going to face is that the context stops here. There is no automatic propagation of the filter context from the bridge table to the account table. So the account table will remain unfiltered, and at the end, the fact table will remain unfiltered. And this is the reason why many-to-many relationships do not work out of the box in Tabular. Let's take a look at what happens. If, let's start from scratch, we have a pivot table. The first thing that we put on the pivot table is the customer name, and we have 4 customers in this data model. Then we put the account. The account name of our data model always shows the names of the customers who own the account. So Luke has an account for Luke and nothing else. He does not have any money on these accounts. But if we simply put the amount on the pivot table, you can see that the result is simply wrong, because there is no filtering of the fact table, and it seems that all the customers own all the accounts. So basically, many-to-many relationships do not work out of the box. But if you just remove this amount and we put amount many-to-many, which contains some DAX code that makes it work, then you see that many-to-many work. Under Marks, you see Mark, Mark Paul, and Mark Roberts, which are the current accounts held by Mark. The problem will just be writing the formula and understanding it. So let's go back 2 slides and move on with some theory. In order to understand the many-to-many pattern, you need to know, I'm not going to explain, and you already need to know, if not your life will be hard for 1 hour, how calculate works, how row context and filter context work, and most important, the automatic transformation of a row context into a filter context whenever calculator is executed. How many of you have a knowledge of the automatic transformation of filter context into row context? 1, 2, 3. Okay, I'll try to explain it very, very quickly. The next slide is the formula. Don't even try to understand it right now. It's not important. But start to look at it and memorize it. Look at the shape it has, because all the times we are going to use many-to-many, this is the pattern we need to use. It's filter over the account or over the farthest table, calculate count rows greater than 0. So we have calculate, we have filter, we have both filter context and row context working together. Later, this is just a first version of the formula, which I use for educational purposes. There are more optimized versions of the same formula, but they are harder to understand. So we start with this, we learn this, and then we will improve performances by using a different phrasing of the same formula. Now, we know the problem, we have seen the formula, let's try to understand what the formula should perform. So what do we do? What do we have in mind when we write the formula? The client, the user, takes the customer and put it on a slicer or on the rows or on the column of a pivot table. So we have a filter on dim customer. And this is what the user does. What we need to do is to take the filter from dim customer and move it to a filter on dim account. Because if we are able to filter the dim account table, then, because we are filtering the one side of a one-to-many relationship, the fact table will be filtered too. Our problem is taking the filter from customer and moving to account. So the formula will basically do this. Take the filter, the already existing filter from customer, then filter dim account, and automatically dim account will filter the fact table. Our task will just be moving this filter from one table to another one. How does our formula work? The first step is applied directly by the data model. We don't need to do anything because customer is on a slicer, there is already a filter on customer, and so the bridge table is automatically filtered by the system because the bridge table is on the many side of a one-to-many relationship starting from the customer. Okay? Say yes sometimes so I know that everything is working the right way. I know it's early in the morning, but it's early in the morning for everybody, me comprised. So let's take it softer. So is it fine? This is the scenario we are going to do. This filter is applied by the data model. Then we have filter. Filter is an iterator that iterates one table, and it's iterating dim account. So for each account, it computes the calculate part. It's filter dim account, then calculate count rows. Filter is iterating dim account, and for each row in dim account, checks whether there is a visible row in the bridge account customer. If it finds one, then the dim account row survives the filter. Otherwise, the dim account rows is removed from the filter. And at the end, the result is a table of dim account, which is pushed on the filter context and automatically filters the transaction table. Whenever I reach this point of the presentation, I always ask, how clear is it? Or if you'd better, how many of you have understood the way the formula works? Okay, how many do not understand the formula? There's always someone lying here, and so in the next slides I will test whether everything is working. At that point, normally the most honest answer I get is somehow confused. I'm start to getting an idea, but it's not perfectly clear, which is absolutely expected. So at the end, once we have created the filter on dim account, we compute sum inside the filter context that shows only the accounts which belong to customers who were originally selected. In order to understand it better, it's useful to see the formula in action, to see how the formula works. And in these slides, I'm showing two different ways of writing the formula. One is correct, the other one is wrong. The correct formula is the green one and contains calculate count rows. The wrong one, which is the most common mistake everybody does using DAX, doesn't contain calculate. And you can see from the result that the wrong formula always computes wrong values, and the correct formula obviously computes correct values. In order to understand why the correct formula works, we are going to analyze the wrong formula and then apply a correction in order to make it work. Sounds good? Move on. This is the wrong formula. We have customers, we have the bridge table in the middle, and we have account. The yellow arrows show the one-to-many relationship. We have a one-to-many relationship. A customer has many rows in the bridge table, and then an account has many rows in the bridge table. That's why we are creating a many-to-many relationship. Our user opens up a pivot table and selects Paul. So it takes customers on the slicer and just select Paul. We know that the first step happens automatically. That filter is moved to the bridge table, and so inside the bridge table, we see just 2 rows because of the automatic propagation of filter context. And now we have our wrong formula. The formula contains calculate. Calculate computes the filter and then the expression. So the first computation that happens is filter dim account. Filter dim account is an iterator over the account table. So it is going to iterate row by row the account table. Let's see what happens. We are on the first row. So filter is iterating our table, and it is on the first row. Now it is computing for the first row count rows bridge account customer. The bridge table is in the middle. And the question now is, what is the result of count rows bridge account customer now? I'm not going to give an answer. I'm waiting for your answer now. Pardon? So the number is 1, might be, 3. Any other number? 5 is interesting, but I want a reason for 5. Even 1 and 3 needs a reason, but anyway, give me some numbers. If I can give you a hint, someone at that point always says error, which might be another. Speak louder, I don't hear you. Just 1? Any other option? So we have 1, 3, 5. Who says 1? That's good. Who says 3? A few. Who says 5? I heard 5. Somebody said 5. Okay. And by the way, who said that he already understood how this formula works? Okay, nobody right now. That's fine. The point is that we are iterating over the account table. And we are counting the number of rows in the bridge table. This is the number of rows in the bridge table which are currently visible under the current filter context. Okay? What is the current filter context? Yep. Paul, Mark. The current filter context is the red part. Because we have a filter context introduced by the selection on the customer, which has been propagated to the bridge table, and nobody ever touched that filter context. We have a row context for the iteration, but nobody is touching the filter context. And the filter context filters 2 rows from the bridge table. And by the way, I guess why nobody said 2. Between 1, 3, and 5, 2 was a good number. But so we are seeing 2 rows in the bridge table due to the filter context. Nobody is touching the filter context, so 2 rows are visible in the filter context. And count rows is counting 2 rows. We have a row context on the account table, but row context and filter context do not interact in any way. We are iterating the account table with a row context, and we are not filtering the bridge table. So 2 is the result of count rows bridge account customer, and for this reason, Mark survives the filter. When it is time to go to Paul, nothing changes. We have always 2 rows visible. Robert, Luke, Mark, Robert, Mark, and Paul, all the rows survive the filter because 2 rows are always visible due to the current existing filter context, which is just the red part. Okay? So this is the reason why the wrong formula does not work, which is expected. It's the wrong formula. We don't expect it to work. Things are changing if we introduce the correct formula. The beginning is the same. We have Paul, and Paul selects 2 rows in the bridge table. Then we have the correct formula, which is very similar to the previous one, but now contains 1 calculate. Filter is going to iterate over the account table. So again, we are following step by step what happens. We are on Mark. This time, we are not computing count rows. We are computing calculate count rows. Calculate has the side effect of taking the current existing row context and transform it into a filter context, then computes the value. This is what calculate does. Among all the other things that calculate does, this is probably the most important and most complex behavior of calculate. If there is a row context, it is transformed into a filter context. So calculate count rows takes the current existing row context on the account table and transforms it into a filter context, which is then propagated through relationships and will filter our bridge table. So the row context existing on the account table is pushed on the bridge table because it becomes a filter context due to the presence of calculate. So now on the bridge table we have 2 different filters. One is the filter, the red filter, and the other one is the green filter, both working together on the same table. Okay? They work in AND. And so now, what is the result of calculate count rows bridge account? 0. The answer now is 0 due to the presence of calculate. And so we drop the row because there is no match between the 2 tables. We repeat the same for Paul. Now the row context is moved to the bridge table, and now we have a match. The result now is 1, because the bottom row is hidden, but the first one is still visible. So Paul survives the filter. Then we go with Robert, and we drop it. We try with Luke, and we drop it. Mark Robert tries harder, selects 2 rows from the bridge table, but there is no hope. It's dropped. Mark Paul again selects 2 rows from the bridge table, and now we have again a match. So at the end, what happened is that we took a filter, an existing filter on the customer table, and by using this iteration over the bridge table, we have taken the filter from the customer and pushed it on the account, selecting only the accounts of customers which have been previously selected. Now, if we take this filter on the account table and apply it as a filter context, which is what calculate does, the outermost calculate, then the sum is computed with a filter on the account table that shows only the account which belong to selected customers. And at the end, you get the correct result. Okay? Does it make some sense? Good. And that's the reason why you will observe this behavior. The amount many-to-many wrong always shows the grand total because it doesn't perform any kind of filtering. It simply let all the account pass by without making any kind of filter. While the amount many-to-many correct correctly filters rows and removes accounts which should not be made visible due to the presence of the many-to-many relationship. So now you know how to write a many-to-many relationship in DAX. The complexity moves from the data model to the formula. but the pattern is pretty easy. Once you understand it, it is pretty easy. And even if it takes some time to correctly understand it, once you get it, using many-to-many is really, really easy. The problem of, the previous formula, the green one, is that it contains an iteration. We need to iterate over all the rows of the bridge table in order to compute, to move the filter. And any kind of iteration in DAX is not slow, but slower than the same computation done without iteration. So it would be nice to have a way to compute the same expression without using filter. Luckily, we have such a kind of expression, which is by using summarize. Summarize is normally thought as a query expression, something that you need to use in order to query DAX, but it is very often used inside formulas, and it's very useful in many-to-many relationship. Summarize does a group by of a table and is able to do a group by using rows from that table or any row belonging to tables related to the original one. So this way of writing the many-to-many pattern is faster than the previous one because we don't have iterations. And since we don't have iterations, the formula is faster. Again, let's take a look at how this works. The beginning is always the same. We have poll, and we have an automatic filtering of the bridge table. And then we have our optimized version of the formula. Think at what summarize does. Summarize takes the bridge table, do a group by over dim account. We have a relationship between the bridge table and the account table. So if you do a group by, if you select account from the bridge table, group by account, you are going to have only two rows, which are poll and mark poll. And you are not grouping by account from the column bridge account customer account, you are grouping by dim account ID account, because you need to have a table of accounts. And this happens as a single vertipack operation. So vertipack takes the bridge table, makes a group by, retrieves the only two rows which are visible, follows relationships, go to the account table, takes the related rows, and creates the result, which is a part of the account table filtered by only the rows which are visible in the bridge table. The interesting part of the summarized version of the formula is that it is much, much faster. It doesn't use iteration. It's just single vertipack operation executing in block mode, so very, very fast. The reason why I normally use the summarized version, but I never teach the summarized version, is because I think that learning it with summarize is harder. It's harder to think in terms of summarize. It's way better to follow the count rows, which is easier to learn. And then we have the third version of many-to-many, which is very compact, very cryptic, very hard to understand, but behaves exactly as the summarized one. It's simply easier to write. If you compute amount many-to-many this way, by doing calculate sum of transaction amount, and you simply put the bridge table name on calculate without doing anything, no filter, no summarize, no operation, just put the table name, then it will work. Learning why really requires some good feeling with DAX. What happens is that bridge account customer in reality is like a bridge account customer with a left outer join with all other tables which are related, and pushing it on the filter context automatically filters all the tables which have a relationship with the bridge table. So at the end, what I suggest you is to learn the many-to-many pattern using count rows, which is the easiest way to debug it and to find whether your formulas are working in the correct way or not. Then move to the summarized version, which is the advanced one. And when you feel confident with the summarized version, try this version, which is the top, because it's very compact, it's very easy, but it's very hard to understand. And it's very easy to make it work in the wrong way, because just by putting the table name, sometimes you put the wrong table name and everything stops working. Many-to-many to summarize is faster. It's easier to code. It's slightly harder to understand. On the other side, the count rows version is easier to learn. And beware that we are going to see a couple of scenarios where the count rows version is still useful. Because using summarize, you can just filter the bridge table, but sometimes you want to search for missing values, and count rows is very, very useful. So our first impressions with many-to-many, if you compare them with multidimensional, is that they are harder to write, but just because the complexity is not in the data model, it is in the formula. In MDX, you don't have to write anything for many-to-many. You just create them in the model. But once the relationship is in the model, you are up and running. In DAX, you need to put it in the formula. This has pros and cons. This might be interesting because you can create much more complex relationships. You are not just tied to plain many-to-many. You can have very complex many-to-many. You can have filtered many-to-many. You can have really, really complex scenarios, and with DAX you can handle them. But if you have, let's say, 20 measures in your data model, using DAX, you will need to repeat the many-to-many pattern for all the measures, because all the measures will need to have calculate my measures and then the many-to-many pattern. Otherwise, they will not work. Okay? And this is not very nice. But it's not a very big problem. I mean, it's pretty easy once you start writing this code to write them. But of course, if your code is going to be very complex, this is not very welcome. Then, cascading many-to-many relationship. What are cascading many-to-many? They are simply 2, 3, 4 n steps of many-to-many relationship from the fact table to the final table you want to filter. Here we have on the top the same example we have seen before, but then each customer can belong to many categories. So each customer belongs to many categories, each category owns many customers, and we want to browse data by category instead of using the customer name. We have really the same scenario, the same examples as before. The problem is that now we need to do 2 steps. We have a filter on dim category, and we need to push it as a filter on dim account. The first step will be move from category to customer, and the second step will be to move from customer to account. And we need to always traverse these 2 paths in order to compute values. Finally, the account will automatically filter the transaction table. Okay? It's not very complex. It's just longer to write. The formula, I'm not going to demo this. It's pretty easy. I'm just going to show you the formula, which is calculate table, summarize. We need to traverse the first step, and this is done by that summarize. The first summarize which is computed is the summarize that computes the bridge customer category and group by ID customer. So we move the filter from the categories to the customer. Once this filter has been computed, it is applied to the data model, and we compute the second step, which is computed by that summarize, a second step of many-to-many pattern. And at the end, we have finished computing our values. So it's the same pattern as before, repeated twice in order to get the final computation. Okay? Of course, this is the summarized version. You can write the more compact version. It's just slightly harder to write and to understand. The cascading many-to-many is very simple to write. It's a generic formula and can work with any number of steps. But that said, don't use it with any number of steps, because its complexity is geometric, so it depends on the multiplication of the sides of the two tables involved in a many-to-many. So if you have 1 million on one side and you have 1 million on the other side, then you have to multiply 1 million by 1 million, and you will get a very big number that I don't even know how to say in English. So it's a too big number. You just relying on the speed of DAX for these kind of numbers is not a good idea. There is another way of using a cascading relationship, which is to flatten them. If instead of using the relationship between category and customers and then from customer to account, you simply do a join between the two tables, write some ETL code and build a bridge account customer category table, then what you are doing is basically materializing the cascading many-to-many into a single table. If you have a lot of rows in both tables, of course, this bridge will be bigger, but at the end, by writing the formula as a classical many-to-many relationship without writing anything strange, you are filtering from categories and from customers the bridge table, and then these two filters will work together with the filter introduced by the iteration over account and will produce the final result. This is an interesting pattern to use even with multidimensional. So it doesn't matter whether you use many-to-many with tabular or with multidimensional. The idea of flattening the bridge, the cascading into a single bridge, might be useful in both flavors of BI semantic model. Generally speaking, it is faster than the cascading one because you reduce the computational steps. The formula will be simpler, and again, it's worth a try in multidimensional. I don't say that you are going to get top speeds, because in general, cascading many-to-many are slow just because of the number of rows that appears in the bridge table, but you can give it a try. Now, we are masters of many-to-many. We know everything we need to know about many-to-many relationships. Let's try to see a couple of examples where many-to-many can be useful, try to understand the formula, how it works, and why it works again. The first example is surveys. Surveys are a very generic data model where you have questions, customers, and you collect the answers to these questions. So one customer answers many questions, of course, and one question is answered by many customers. Again, we have a many-to-many relationship. The difference between this data model and the previous one is that now the fact table is the bridge table. If you think at it, the fact table creates a many-to-many relationship between any two dimensions. We normally think about many-to-many as relating two dimensions and then a fact table, but any two dimensions in a dimensional model are related through a many-to-many by using the fact table as the bridge one. And this is what we are going to use in the survey data model. We want to use a pivot table to query this data model and to answer a very simple question, which is what is the yearly income of consultants? One of the questions inside our data model was your job. So if you answered consultant at the job question, then we made a different survey, which is what is your yearly income, and different customers answer the question. What we want to do is to take all the customers who answered the consultant at the job word and slice them using the answer they gave to the yearly income. So this is a very generic data model that solves a lot of different problems, a lot of different questions. It's not very fast, but it's very, very powerful. It answers a lot of different questions. In order to make it work, we will need to create two instances of the filter table. This is the analytical data model. Before we have seen the relational data model, the analytical one should be slightly different because we have customers, we have the fact table in the middle containing answers, and then we create two different filter tables, which are just two roles, two role dimensions for the answer dimension, where we have denormalized question and answer. The reason why we need two is that we need to cross two different questions. One is the job, and the other one is the yearly income. So we need more than one instance of the filter table. And if we want to cross three questions, then we will need three instances, and so on. The final result we want to achieve is the number of customers who answer different questions. And again, so the measure we are going to do is simply a count of the number of answers, and the fact table will be the bridge one. I was expecting to see the demo slide, and I don't see, so let me just check whether I forgot it. Yeah, I forgot the demo slide, so I'm going to show you the demo without demo slide. Here we are. The final result that we want to get is this one. Here we have question one, gender, job, the answer user gave to question one. So we can select, for example, gender, and select only customer who are female, and then the yearly income of female. Or we can select movie preferences, horror, and then we get the yearly income of people who looked at horror films. And of course, we can decide to slide by gender, by movie preference, by sport, by job, by whatever you want. Okay, this is the final result we want to achieve. And that's the reason why we have question one, answer one, which is one dimension, question two and answer two, which is on the rows, which is another dimension. If we want to cross more than one, more than two, we need to make it in a different way. We have a problem in this data model, and it is that we cannot create a relationship in the data model between the fact table and the two role dimension because of limitations in the tabular data modeling options. Since we have only one ID answer, there can be only one active relationship between dimensions and the fact table. We cannot have more than one, or if you do that, you will get wrong results. So we need to write the formula in a slightly complex way. This is the formula that computes numbers you have seen before. Let's try to take a look at it pretty quickly. The first if is used only to check whether some selection has been done on the slicers. So ID answer 1 on filter 1 and on filter 2 should have only one value. That basically means something has been filtered on the slicer. Then you see that the black part and the red part are two instances of the many-to-many pattern. But this time, we do a filter of the customers, and we compute the number of answers that should be greater than 0. So this is a many-to-many pattern. It's not different from the many-to-many pattern. But this time, it's more complex than the classical many-to-many pattern, because inside the filter, we even add an additional condition which creates the relationship we have not been able to create in the data model. We cannot create the relationship between ID answer and ID answer in filter 2 and filter 1. We cannot create the relationship in the data model. We create it inside the formula, and so it exists only during the formula execution. This pattern shows you the power of DAX because we are creating relationship by need only when we want them to be active. The same pattern can be solved in multidimensional too, but in order to solve it in multidimensional, since you will need to model the relationship in the data model, you need to duplicate the fact table, which normally is a big table. Here in Tabular, you need to duplicate only the dimension, which is normally a small table, and you don't need to duplicate the fact table because you can create relationships on the fly. So survey is a very powerful and compact data model. Don't even think to use survey to solve all of your problems because, of course, for big data sets, it's going to be slow. The speed of survey really depends on the size of the question and answer table, not on the size of the fact table. So you can have a very big table, but if you have, let's say, 10,000 answers and 10,000 questions, speeds start to be slow. But if you have just a few hundred or a few hundred, I think, questions, the speed is really, really good in Tabular. And the data model is pretty easy to write. It handles any number of questions. And the interesting topic here is that we are using the fact table as the bridge. We are not using a real bridge table. Another example where, again, we are going to use the fact table as the bridge is basket analysis. Basket analysis is a very common pattern, a very common example that happens pretty often, and it is really, really hard to solve in multidimensional, but pretty easy to solve in Tabular. This time we're going to use AdventureWorks. We have a fact, internet sales, time, product, customer, classical star schema, nothing strange, not a big and complex data model here. But the question we want to answer is, listen, of all the customers who bought a mountain bike, so filter the customer and select only the one who bought a mountain bike, and of this customer, tell me how many of them never bought, from me at least, a mountain tire tube. And this is a very common scenario, a very common question from marketing people that says, if the customer normally buys this product, then he probably wants this one. If he hasn't still bought it, then I want to go to him and make a proposal because probably I'm going to make business out of that. If you think about solving this problem in multidimensional, it's not an easy problem. Solving it in multidimensional requires really complex data modeling because we are not searching for an existing relationship. We are searching for a missing relationship. We are not searching for a customer who bought both, but we are searching for a customer who bought one and didn't buy another one. And modeling non-existence in multidimensional is really, really complex. At the end, in multidimensional, you end up modeling the opposite. So you end up writing a data model where if the customer did not buy a mountain tire tube, then I write a row inside my fact table because I can aggregate them and I cannot aggregate non-existing values. You can solve it in SQL. In SQL, it's pretty easy. But in order to solve it in SQL, you need to do a select from sales, inner join, again, sales. The customer should be the same. And on the A instance of sales, you will select mountain tire tube. And on the B instance of sales, you select mountain bike. This works. It works pretty well. And it's a classical and canonical solution in SQL to do basket analysis. The problem is that if you take a look at the query plan of this SQL query, you see that we have only one hash match. The problem is that the hash match exists with the fact table. So the query plan is making a self-join of the fact table. If it contains several millions or billions of rows, of course, you are going to have problems of performances. You can create indexes, you can improve performances. I don't want to spend time here. The point is that in order to solve a basket analysis, you need to do a self-join of the fact table. It's the only way to solve it. In Tabular, we are going to solve the problem in a slightly different way using the many-to-many pattern. First of all, we need to slightly modify the data model because we can filter mountain tire tube, for example, on the DIM product table. But we need to filter mountain bike too. So we have two filters that need to apply to the DIM product table, and we have only one instance of the DIM product table. So in order to solve the data model, we need to slightly modify it and create two instances of the dim product table. On one, we will filter mountain bike. On the other one, we will filter mountain tire tube. And we are going to create only inactive relationships between the sales table and the product table. Inactive relationship, in the example I provided you before, we didn't create relationships and then we created them on the fly. In this example, we are again using the fact table as the bridge table. We have two instances of a dimension. We create the relationship, but we make them inactive. And then we will activate relationship by need. So there are two different ways of performing the same operation. And it's just a matter of taste, the one you prefer. From the performance point of view, this version of activating and deactivating relationships works slightly better. The final result, I think it's easier to take a look at the final result on the demo machine, is pretty simple. Let me see, basket analysis. This is the result we want to have. We create a slicer here, where we select a mountain 100, 200. These are different model of bikes, and I put them on rows. And then from this slice, I select mountain tire tube and patch kit. And I have two different measures. One is having product, and the other one is not having product. Having product shows the number of customers who bought both a mountain 100 bike and a mountain tire tube. Not having product are people who bought a mountain bike but never bought a mountain tire tube. And this is the final result we want to achieve. Of course, by changing the filter or by changing something in the model name, everything will change. But the point is not looking at how things change. The point is understanding how to solve such a model using many-to-many. So we have two filters on slicers and then two different measures we need to write. We have inactive relationships. So the relationships are there. They have been created in the data model. They are not active, and they will not be used if you don't manually activate them. The formula is pretty easy once you understand how many-to-many relationships work and, most important, why they work this way. If you take a look at it, it's, let me see, okay. We have two instances of the many-to-many pattern. The first one is calculate count rows sales greater than 0. So I should have something here to highlight. This calculate is the first many-to-many pattern, and this second one is a second many-to-many pattern. And the difference between a classical many-to-many pattern and this one is that now, inside the calculate, we add the condition use relationship. In the previous formula for the survey, we created the relationship at that point. Here, we are only activating the relationship. And this is the formula for having products. So we are filtering the customers where there is one sale of the first product and there is one sale of the second product. So we are simply filtering all the customers who bought both products. And having product is not very hard to solve. It's pretty easy because we are checking for existence of relationship. The customer should have bought both, and there are easiest way to write the same. The point is that not having product is exactly the same formula, but this time we have a different condition here. Instead of checking that the relationship exists for both products, we check that the relationship exists for one product and does not exist for the other one. So searching for missing relationship is easy as it is searching for existing relationship, because writing that in DAX, the DAX code is slightly harder, but once you master it, you will be able to solve both a positive question and negative question pretty easily. Again, I'm not saying that it's an easy formula, but it's not in reality very complex. Once you learn the many-to-many pattern, writing this formula is pretty easy. Not very, very easy, but not very complex. And where are the many-to-many in all this data model? This is the first many-to-many pattern with the classical greater than 0, and you can write this many-to-many pattern using summarize or using different ways of grouping data. The second many-to-many pattern is there, so most of the formula is just one pattern. The point to note is that this time the pattern contains equal to 0. So you cannot use summarize. You cannot use the table name version of the formula. Here you need to use count rows. So you need to iterate over all the customers and do the count rows because you are searching for missing values. Okay? In order to make this formula work, we have used several tabular features that are multiple relationship between tables, that is role dimensions and role keys, active and inactive relationships, so we activated and deactivated relationship depending on what we need, and use relationship, which is a new function in SQL Server 2012 that makes this kind of formula work better. Now, finally, once we have learned how many-to-many works, we spend just a few minutes looking at them working. I'm going to show you more or less the same demos you have already seen. This time we simply stop for a few minutes on the formula in order to understand why they work, how they work, and what are the performances of formulas using many-to-many relationships over our 4 billion row fact table. And I'm going to explain you a bit more about the data model and why we decided to go tabular with this data model. This is a data model we took from a customer in Italy that does audience analysis of television broadcasts. What these guys do, they simply give to some people, to some individuals, a special remote control that controls television. And then whenever these guys change the channel, the information is kept from a box that stores information about who was watching which channel at that point, at a specific point in time. Something like a big brother that looks at you and tries to understand your behavior in front of the television box. So the fact table is very simple. We have the audience table that says that one individual in one point in time was looking at one specific network. Then we are not interested in any way in behavior of individuals because individuals are too many, and I'm not going to advertise for just one individual. Individuals belong to targets through categories. A category can be women, men are categories, and living in big cities is a category. Having 2 children is a category. The target is advertisement target. So all women living in big cities with more than 2 children is a target. I want to advertise to these kind of people. And this is the reason why there is a many-to-many relationship between individuals and target, because a single individual can belong to many targets. The first time I saw this data model was in multidimensional, and I said, okay, there is no problem in solving this data model, just remove the many-to-many. Because the sides are too big, many-to-many will not be good, and you need to remove the many-to-many. Then I learned the kind of analysis advertisers do. And a classical query might be, listen, take all the people who looked at least 10 minutes of the last 7 episodes of Dr. House and show me what they are looking now. In order to solve such a query, you need to have the many-to-many. You need to compute the first set and then create the many-to-many and then do a second pass in order to solve the problem. So many-to-many are needed here. We cannot avoid them. And the customer was used to wait a few minutes to have answer to different questions. Only because the numbers are pretty small for most of the table. We don't have big numbers in all dimensions. We don't have big numbers too in the target table, but we have a pretty big data set on the audience table. This is our 4 billion rows fact table, which we need to query. And the queries we need to do starts from target and need to take the filter from target, push it to individual so that individual will filter the audience table and give us the final result. Okay? So our work has been that of trying whether Tabular is fast enough to solve this problem and to give good interactivity with the customer. Let's take a look at queries. Okay. This is useful just to check. Okay. We have our 4 billion rows here, 2.7 million in the bridge table, and 152,000 rows. If you remember the formula, the many-to-many formula, the real size we matter is the bridge table. So having 4 billion rows is a good thing, but the formulas are really, they're really dependent not on the size of the fact table, but on the size of the bridge table, because this is where we do the summarize. This is where we do the step of filtering. So the speed of all this formula really depends on the size of the bridge table. 2.7 million is not a big number. You can go to 10 millions without having a lot of problems. If you have 100 million rows in the bridge table, then you start having problems. But at that point, probably you have problems in the data model, because 100 million rows in the bridge table is something that probably needs different data modeling. If you are below some millions, everything will work pretty fine. Let's skip useless demos, because this is not very interesting. I want to show you this query, because it's the first one where we can see some interesting number. Here we are doing a summarize of the fact table, which is the audience. We group by gender, age range, and we simply compute the number of rows and then the weighted mean age. The point is that we filter inside calculate table. We are filtering here the target. Maschi is Italian for male. So we are filtering only male from the individuals and taking a look at what they were looking at in January 2010. If we execute this query, oh, let me ask it to you. It's easier. What the result is it going to give us, this query? Are we going to see only males? Are you still awake? Yep. Okay, you're laughing, so at least somebody is still awake. We are filtering the targets. Targets is far from the fact table. Target is tied through the bridge table to individuals. Individuals will filter the bridge table. But since we are filtering targets, we are not filtering individuals. And so if we execute this query as it is right now, we are going to get as a result males and females. Again, Italian, but the concept is that we are looking, the filter on the target doesn't filter in reality numbers. We are not really filtering, because filtering the bridge table doesn't push the filter to the fact table. If we want to make it work, we need to use the many-to-many pattern. And here, I start with the easiest one. I use calculate table, and here I put bridge individual targets. This is the easiest way, the shortest way, if you prefer, to filter the bridge table. You can see the formula this way, and here you can see the summarized version of the same formula. It's easy to write the count rows version. It's the same, always the same way of computing values. If you execute the same query, but this time with the many-to-many pattern, you run it, and you get the result. Of course, now I'm cheating because I haven't cleared the cache. So let's do it just because I want to show you the usage of cache in multidimensional, in tabular, sorry. This is the pattern with the bridge table. If we run it, now it's going to take more than 1 second, of course, because it is not in cache. But in 7 seconds, we get the answer. Keep in mind, in order to get the same answer, and it contains only male, female are disappeared from the data set. In order to get the same answer on multidimensional, the multidimensional data model, the customer was used to wait between 2 and 3 minutes just to get this answer. And he was pretty happy with that. Getting the same answer in 7 seconds is really cool. If you use bridge individual targets, this version of the formula, you are going to have exactly the same performance as if you use the summarize. In fact, remember before I cleared the cache, so the only result which is now contained in the cache is the result of the previous query, but if we execute this query, which is different, we get the result immediately, meaning that the result is already in cache. So the two formulas produce exactly the same query plan. There is no difference between them. Just choose the one that best fits your needs. And it is interesting to see that for many-to-many relationships, the cache of Vertipack works perfectly. If you execute the same query twice, the first time you pay 6 seconds in order to compute it, the second time execution is immediate. So even if you have a large data set, you can really leverage the cache in order to build a good cache after the few minutes of work of your server, and the user experience will be pretty good because hard computation will happen only once during the period when your customer works. Okay, let's go to the conclusion. Conclusions about many-to-many. How can you make many-to-many work in Tabular? Learn DAX. I think that all the sessions that I'm doing in the last couple of years, they all end with learn DAX. Seriously, learn it. It might be because I normally teach DAX, so it's just advertisement. But in reality, I really believe that if you want to use Tabular, you need to spend a lot of time on DAX. DAX is your only tool. It's the only tool you can use to create complex data model, to make speed, to make a quick model, to make fast model, and to make your customer happy. And learning DAX is not easy. As you have seen, when you start writing queries with many-to-many relationships and with complex relationships, understanding what's happening inside the formula is not something very easy. You always need to stop, read the formula, try to understand it, and then you get some result. If you want to learn many-to-many, study the count rows version, which is the easiest one. Then never implement the count rows. Always implement with summarize or with table filtering, the one that best fits your taste. It's not a matter of performance. It's just a matter of personal feeling. If your summarized version is not enough because you need complex relationship or you need to search for missing relationship instead of existing ones, then revert back to count rows, which is slower but more flexible. With that, you can create complex relationship and search, for example, for missing values, as we did in the basket analysis pattern. When it comes to performance, there is a clear winner for what concerns many-to-many between tabular and multidimensional. Multidimensional is normally slow. Tabular is incredibly fast. You can really use many-to-many relationship. And in my opinion, if you have a data model containing distinct count or having many-to-many relationship, this is the perfect candidate to move on Tabular, at least to build a prototype. You have it working in multidimensional, give it a try with Tabular. You will probably be surprised by performance. And if not, the reason will probably be that the DAX code needs to be optimized, the DAX code or the data model, because as you have seen, the speed you can get is really, really huge. It's just a matter of writing the DAX code in the correct way. Related content. There is my session there. I always forget to remove my session from the related content, but you have a hands-on lab and you have other places where you can look, track resources, and then, oh, this slide, I just left this slide here to show you the book, which is, I think it's going on print next week. So at the end, it will come on Amazon pretty soon. And there you will find a lot of description and a lot of content about SQL Server 2012 analysis services, Tabular, and there you have many-to-many and all the stuff we know right now about Tabular and multidimensional resources. And then finally, evaluation. Always remember to submit your evaluation. We are really eager to read evaluation because we want to improve and we want to understand how things can be made better. But we are even fighting speaker versus speaker to decide which is the best one, so we need evaluation in order to win the fight. And it's very important for small sessions like this one, because I don't know how many we are, but I think 30, 40 people. We need to have at least 10 evaluation to win. So please provide evaluation, otherwise I will not be ranking and I will be a very sad man. You don't want me to be sad, so do that evaluations. Thank you very much for your attention. If you have questions, of course, I'm here. You can do questions now. You can do them question later. You can reach me at the Microsoft booth without any problem. So is there any question? Yep.
Have you used several bridge tables in the model? We have a situation where I want to use many different types of slicers for different categories, and that means, from what I've seen so far, I need several multiple bridge tables.
Yeah. So I need to repeat the question for the recording. The question is, what happens if you have more than one, not a cascading many-to-many, but many-to-many relationships, so many bridge tables. And what basically, that should work without any problem. You just need to repeat the many-to-many pattern for all the bridges you have. So if you have 2 bridges, you need to do calculate your expression, the many-to-many pattern for one bridge, and the many-to-many pattern for the other bridge. And they will be executed together, then ended together over the fact table, and you will get the correct result. I have never tried it, but it's pretty simple. We just need a data model in order to try it. Writing the code is